So you want me to start?
I would.
You're picking the youngest person when you're saying you want to go back to the history.
It's Back to the Future, Kate.
I mean, well, I mean, so what I can tell you where I came into this topic 10 to 12 years ago, really. So that's not that long ago. In detail, you know, I started trying to understand whether, you know, I was working with a team that was going to be importing aluminum curtain wall from Asia with the idea that we'd make zero energy homes. And it started quite, you know, what could you actually make a green home out of high energy material that you shipped across the world? And I tried to figure out how to calculate. So, you know, in that group, we decided that, you know, you couldn't build a green home that you imported stuff unless you offset the carbon footprint of the manufacturing and transportation. So that got me going down the line of trying to figure out what the numbers are. And that then connected me with some of, you know, the early work like that Pliny had done or that was happening at Athena and the data that was there. And it was kind of interesting because I think, Pliny, you told me that it was a useless endeavor. Something along those lines. The data is just too much. It's just like way crazy, too much data, and it's too difficult to get it. Something along those lines, which I think is in some ways an accurate assessment, but in other ways, I didn't. I kept trying. So I think that it's a really life cycle assessment is really a relatively young discipline. So when I was starting 10 years ago, the people that had done it you could count on, you know, your hands, and it was not just people had tried it and had challenges. You know, there was the NIST database, the US LCI Commons was kind of, was a mess. And a few people tried it and people came to different conclusions. Individuals came to different conclusions about what was happening. So I found it interesting in that sense because it reminded me of, or it made me imagine how engineering disciplines evolved when there wasn't broad consensus about a method. You know, like in engineering, there's the allowable stress method and the LRFD method, and there's clearly defined rules and processes. And life cycle assessment wasn't there. And there were strongly held points of view, but not a broad consensus. So I think that, I think that we are in a really interesting stage. If we're just talking about embodied carbon data, so I'll be the embodied carbon data geek on that point. We're at an interesting stage because many more people are creating the data, using the data, working with that data now, but we're not yet at the sort of a steady state of people understanding it in a completely shared and aligned methods. So, but we are at a place where we have enough expertise that you can get a more sophisticated conversation that's not so personal. I mean, personal is not quite the right word, but you know, you can start to get to a consensus based on a larger body of people that have domain expertise. So for me right now, it's really interesting because when I start, you know, if I go back 8 years ago in the Carbon Leadership Forum group, again, you maybe needed more than one pair of hands, but you knew who was doing what, and people could get together and have a conversation. And now there's, if you're hearing people talk about using life cycle assessment all over the place. So if you're just talking about that's my data story. I think on the movement story, I think that it would be really interesting to hear your all's perspective on sort of the cyclical nature of excitement and action on the topic. And because it seems to me, I caught the tail end of a push as a student in the 80s that kind of disappeared in terms of a focus. And then, you know, now it feels like there's a much it feels in the exponential point of people paying attention and figuring out ways to act. So I'd be curious to hear what you guys think about that.
Okay.
Is this the kind of thing you wanted to talk about, Bruce?
Ed, I'm
Yeah.
going to let you go next, but first I'm going to interject in my role as moderator for the benefit of those who will be watching this recording that Kate has once again failed to toot her own horn at all properly. I'd say you actually failed, Kate.
I have a question.
If I
On,
may, let me just, Kate went on to the faculty at the University of Washington and then founded the Carbon Leadership Forum. Somehow I remember the day you called me and said, I'm thinking of starting this thing. I was working on the Yates Holland House. I was on their property, and you'll remember that. But and it was just bing, what a great idea. Of course. Yes, of course. And we talked for an hour. And now the Carbon Leadership Forum is a big deal around the world, and its offshoot, the Embodied Carbon Network, perhaps exemplified best by the fact that I was, long story short, I was given a tour of basically the barrios of Cairo by this Egyptian architect, and he kept looking at me and saying, I know your name, I know your name. Finally said, oh, right, the Embodied Carbon Network. Guy was on the Embodied Carbon Network in Cairo. So Kate, you've done an enormous thing by establishing infrastructure for us to work these, how do you do LCA, but to talk to each other and to bring a whole lot of stuff forward. And you deserve enormous credit for that. So.
Well, thanks. I didn't go into my pitch thing. I think I would agree that the network, so that has grown into regional Carbon Leadership Forum hubs, and as well as the online network where people are posting and sharing information. And so it's really interesting on how you might be able, and actually that was inspired by Vince Vince Martinez from Architecture 2030, who gave me a book on the power of networks and networks to inspire change. So, rather than having top-down control, how do you provide enough framework and information to empower many people to act? So it's pretty, yes, I am excited about that.
hey, Kate, I have a question. Was it 2010 in Portland that we met at a dinner?
It would have been right around 2010. Yes. Yes.
There was a conference in Portland on embodied carbon, and I think it was you and somebody from Central Concrete asked me to have dinner with you guys.
Yes. And I'm not quite sure why you were in Portland then.
There was another conference going on architecture and energy. And at that time,
okay,
it was a big conference, and I got this call. I think it was either from you or can't remember the gentleman's name from Central Concrete, but
I think it was Chris Erickson who was
Chris,
doing
that's right. It was Chris.
But from Climate Earth, but yes.
Yeah.
I do remember that.
Yeah. And said, can we have dinner with you? And we had dinner, and I remember you guys at that time asked me, by that time, the 2030 challenge was going and it was getting adopted and everything else. And we had established targets and a framework and everything, and the AIA had adopted it. And you guys asked me if we could establish targets for embodied carbon. And I didn't even know there was an embodied carbon conference going on. It was going on in Portland, and you guys were there for that. So I didn't even know it was going on at the same time. But anyway, I remember that. And that got us into that. So I'll explain that. But I just wanted to make sure I had the right date, I looked up.
I think after talking with you that night, I went and wrote a white paper.
Oh, okay.
Because you were sort of like, well, show me more about this.
Yeah. Okay. No, I just wanted to just refresh my memory, make sure that it was you. Yeah. No, I remember the dinner, and I remember the table. It was a round table, and I kind of remember a lot of that. So anyway.
So Ed,
you want me
you've
to
done
go?
a bit of work around carbon, I think, right?
Yeah. So yeah, I'll give you a quick rundown. And it's interesting actually. Way back in the 70s, when the oil crisis hit, I was at the University of Oregon, and we were doing work on passive solar, passive solar energy systems, and trying to figure that out, how the heck they worked and what the targets were and all that kind of stuff. And and at that same time, a guy named Richard Stein, I don't know if you know Richard G. Stein, he wrote a book,
Energy and architecture. Yep.
Architecture and Energy. And so it was, his came out, I think, just before mine, but we were writing it at about the same time. So at that time we were focused mostly on operational energy, right, and passive solar systems. So that was so that took place in the late 70s and early 80s. The book came out in 79, and we had the whole passive solar conferences and everything else. Well, when Reagan got in, things didn't go, they kind of went dormant in a way, but more under the surface. People were still working on stuff, but it wasn't like what it was in the late 70s, early 80s. In 2002, we were, by that time we had a practice and practicing architecture in Santa Fe and had a fairly large firm. We were doing these Friday afternoon teaching moments for all the young architects in the office who wanted to know about the work we did back in the 70s. And at that point, somebody asked about climate change. And so I said I would investigate it and what our role was. And so I went back and started, there was no building sector and there was no architecture sector. And there was, essentially the pie was, it was automobiles and transportation and industry and electricity. And then it had two little teeny slivers for residential and commercial, which was like 1% or 2% or something like that. And it was essentially what was burned on site, which was natural gas. And that was it. And so nobody ever, so we didn't think it was our issue at that time in terms of emissions. And diving into it, we started to plug in the electricity sector on what we were responsible for. And then I went back and looked at Stein's book, right? And if you look at Stein's book, he deals with, for the first time, embodied energy in buildings. And in the notes back in the back of the book, I'll show you guys anyway. He had,
remember the date of that book, Ed?
this was 78.
Because I had Philip Stedman's book and when I was in engineering school in the 70s.
This was 78. And there was a study that was done, energy in building construction. And it was a grant from the U.S. Energy Research and Development Administration. And he had broken down all sorts of building types and the square footage and, roughly, and then the embodied energy for those buildings. And, it was very complex. So he tried to trace it all the way back, right? This is kind of a, the next page of that, trace it all the way back to transportation and going all the way back and each one. So anyway, we used that and we then created a new pie chart, and we came up with almost 50%, 48% of all the energy used in the US went to what we did as architects. And about, I want to say 6 to 9% based on Stein's work, we calculated roughly that was the embodied energy part of it. So we added that in to create the architecture sector. So that was the first time we had really dived into the situation. So the 48% or close to half of all emissions included operational and embodied energy. So that's how we came up with that. And then we came up with reduction targets back then, and we put out the Architects Pollute issue in 2003. We came out with reducing energy consumption in all the different facets of architecture. And one of them was obviously embodied energy. So that was all in that architects pollute issue. So there was a piece on embodied energy there. Then, so it kind of went, we then focused mostly because most of the energy consumption on an annual basis in architecture itself, not if we go, site work, and not if we go, out into infrastructure and stuff, but just in the building itself. Most of the energy consumption was operational from the whole sector. So we focused on that for a while. And then in 2010, I was giving a talk in Portland, a keynote at a conference, and that's when I got that call from Kate, and to have dinner. And they asked, so we were having quite a bit of success in moving the targets. At that time, the 2030 challenge, it was getting adopted everywhere, and we were moving it. And the conversation, as I remember, Kate might have a different take on it, but because it was a long time ago. But the conversation was, can you create targets like you did for operational, for embodied energy and emissions? And I said we would look into it. And I went back to our office, and we didn't have much contact. I put Francesca Damaris, I don't know if you remember Francesca, on it, right? And I said, Francesca, we'll meet, every other day. You do research on this, and then let's figure out a way to develop targets. She said, okay. In my heart of hearts, I knew that it was going to be almost an impossible task, because I had written specs for years on, for all our projects. I was actually not only the lead designer, but I was the spec writer, and there are millions and millions of products to choose from. And I said, no way we're going to ever get a handle on this, because it's a monster. There are just millions of products. How are you going to get, decide on what to do? Anyway, Francesca kept going at it. We got to do this. We got to come up with targets. She kept, we'd sit on a board and do all this work, and we could never figure it out. Finally, this went on for a year. I swear, every other day we met, and she was badgering me. We've got to develop targets, and we'd come up with all sorts of schemes. We finally came up with a scheme and put out on Valentine's Day in 2011. So a year after, almost a year and a half after we met with Kate and had that dinner. And I have to admit, it was I was a little reluctant to do it, but we had kind of figured out that we would develop 35, 40, 45 to 50 by 2030 reduction targets in product categories, because it was so complex, the product category rules, and you had to have an industry all get together to develop a baseline and all that. So we figured, let them do all that work, and we'll just call for the reduction targets and put them out. So we did that on Valentine's Day. We did a big splash, and we put out the reduction targets for embodied carbon. So that happened in 2011. In 2013, then the National Concrete Ready Mix Association adopted the targets and asked me to give a keynote at their annual conference, which I did, which got a little dicey because of the coal ash people and everything else we were calling for eliminating. And so anyway, it was a little dicey, but anyway, they adopted it, and that was sort of big. And then in 2014, I did a little chronology last night. In 2014, you guys invited me to Buildwell, the first one over. I guess it was in Marin or across the bridge.
Yeah, San Francisco.
Yeah, and that was the first Buildwell I attended. And so embodied carbon started to become a thing then, and was kept pushing the targets. And in 2015 at Buildings Day in Paris, in the keynote that I gave, we talked about operational, but we honed in on embodied carbon also, and that we have to get a handle on this. And these were the targets. We were still based on those targets. So that was 2015. And so we pushed it in Paris. And then in 2017, there was another build well. And that was, I remember, in San Francisco.
Right.
And there we had come up with, or somebody had come up with, I can't remember, with the core and shell being 49% of all of a building's emissions, roughly. And so we started to get our head around it, that there was actually you can focus in on something and get a bigger chunk rather than the hundreds of millions of materials. And so by 2018, there was the Climate Action Summit in San Francisco, and there we did another. So there was Carbon Smart Buildings Day, which Kate.
But you forgot a good one, Ed.
What was that?
You forgot the second build well in the San Francisco Presidio.
Well, no, he got it. He got
No,
the
I
first
got
one
that.
was in Marin. The second one was in the
Yeah,
Presidio.
and the second one was in Presidio because
That was 2017.
that was 2017 because you're like
Yeah.
hanging. So it's dinner before, and you're talking the next
Oh,
day.
right. I remember
And
the
then-
dinner.
and
now.
the dinner before, you're like, Kate, I have this idea. I'm going to tell everybody that we have to get embodied carbon down to 0 by 2050.
Mhm.
And I was like, Ed, I laughed. And I'm like, oh my gosh, Ed, that's crazy. There's no way you could get embodied carbon to 0. There's like, natural gas and chemistry and all that sort of stuff. And
I pushed
I
you
was
guys to
bad.
develop. I pushed you guys to develop benchmarks.
yeah, well, that was
I
before
remember at that
This was-
dinner.
You're like, oh, we've got to set a target of 0. And I was like, and I went to bed and slept on it. And by the next morning, I was like, yeah, okay, that's what we got to do. That's what we got to do.
Yeah.
You're right.
Yeah.
That was a good one for me.
Yeah, I remember that dinner. That was actually a great dinner. That was
What?
not only the dinner, but just the talk. And that's when we pushed that. And then, so in 2018, that's when that's at the keynote, the early keynote, that's when I put out that 2050 date also, was at that time. So still the only thing we had was the 2030 challenge for products. And it was still daunting, And so by 2019, in the first Carbon Positive, we had 2019 and 2020, we had two big conferences, one in Chicago and one in LA. We hit on looking at the attributes of materials and thinking that if we just focused on the attributes, we can reduce embodied carbon, put out specs and on attributes and reduce embodied carbon. And also in 2018 in San Francisco at the summit, we had developed the materials palette and kind of, promoted that at that time. So that was the first time that the palette came out, and we were working, Lindsay was working on that. 2019 and 2020, finally looking at data, the International Energy Agency data on the industrial sector, we finally hit on a graph that showed that steel and concrete were half of all industrial emissions. I almost fell off my chair when just two materials were responsible for 50% of all of the entire industrial sector. So that's not all the other materials that go into buildings, from HVAC and lighting and carpet and wall base and you name it, sheetrock, ceilings. But that was spoons and forks and pots and pans and bubblegum wrap. I mean, everything, the entire industrial sector. There were just two materials, and they were mostly, when I did other research, they were mostly used in not only buildings, building structure and substructure, but also in infrastructure. So roads and bridges and, you know, site work and all that kind of stuff. So these two materials that we were, our architecture and planning, when you put in the planning sector, was responsible for, we could get at half of all industrial emissions. And so that's when we kind of unleashed that in 2019 and 2020, and that's at Carbon Positive. And then we kind of try to explode that at the teach-in this year. So that's roughly where we are now, is we can get a handle on it all. And it's very similar to the big buildings, small buildings concept that we came up with. There are relatively few buildings responsible for almost half of all emissions. So you can get a handle on that. You can give them dates certain, you can push them, they have money, you can do that. Same thing with embodied. Go for the, you know, go for those two materials, get them down while you're working on all the others, and get them down quickly to 20, by 2030, get them to zero. And then you have to 2040 to get the entire industrial sector, which will follow. So anyway, that's our strategy today, but that's the scenario of how that all happened, you know, from going all the way back to the 70s and 80s. So anyway, you got
So
the whole story.
I want
So
to.
Bruce,
I'll
I'd
let
like
you
to
take
pick
over,
up on,
Penny. I want to let you, but I want to interject here again, because Ed, you mentioned the climate summit that Jerry Brown did in San Francisco 2 years ago, and we did our Carbon Positive thing there. And leading up to that gathering, a number of us, including on this call, tried to work out our terminology. You still today hear people, you used carbon positive, others use carbon negative. If you get your carbon emissions, embodied or operational, down to zero, that's great. Zero, net zero. What if you keep going? What do you call that? Ed calls it carbon positive. Interface calls it carbon negative.
Yep.
We decided to call it carbon smart. Nobody was ever real that excited about it. So for the benefit of any of you listening to this recording, we still haven't figured out what to call it when you do better than zero, when you're actually storing carbon in your buildings and building materials.
Well, let's hopefully we can you know, all get to carbon positive. And the reason I say that is we're now at the beginnings of well, we had the global teach-in, and you know, we termed that carbon positive, but now we're at the beginnings of a huge event just prior to the COP in Glasgow that'll be held in London the week before the COP. It'll be right now that we're in the early planning stages, so it's just trying to get the parties together. But we will. So the AIA is behind it. We're talking to the RIBA and a bunch of other organizations, but and we'll obviously embodied carbon will be a big part of this, and we'll get Kate involved and everybody else involved, the network. But it's going to revolve around that, around carbon positive, getting the whole industry past zero and into carbon positive territory, to give the countries the confidence to up their targets in Glasgow, that the building sector and the built environment is committed to moving in that direction, and we will get there so that you, the countries, can you know, increase your ambition to meet the 1.5. So it'll be called the 1.5 degrees summit, climate summit.
When is this
so can I
Glasgow?
go?
Yeah.
It'll happen. We're working on the date now with RIBA.
Oh, just roughly. I mean, it's
week before, yeah, in November, the end of October, because the conference starts the first week in November. So this will be the last week in October, roughly.
Plenty Fisk. Would you please tell us?
I just
about
want to
yourself?
make one quick comment about Ed's great presentation and history, and that is Stein's work. Can anybody hear me, by the way?
Yes.
We can all hear
Good.
you.
Okay. The model that Stein was following was an extremely sophisticated model. And that was that he was the first one, to my knowledge, to use the IO tables of the US economy. That's how he derived his hierarchies. That's what we picked up on with EPA and Greg Norris and a whole bunch of people,
Yeah.
IAIA and so on, to say we need a tool set that is really basic to everyone: industry, housing, wastewater, you name it. And so we can really get a perspective across the entire board. And that work with Stein's stuff was it. I mean, that's what triggered things. But I'm going to go back, so I'm probably the oldest guy here. So my stuff came from Ian McHarg, you might imagine. And it wasn't because McHarg was saying this. In fact, the thesis that I took on was the fact that he had no solution for a huge problem, and that was to save the Hackensack Meadows in New Jersey. And the Hackensack Meadows is a huge wetland, 18,000 acres. And so there was a studio that was paid for by the state of New Jersey to save the meadows. And no one seemed to be able to figure out how to do that, because McHarg's overlay process saved 1.5 acres out of 18,000 acres of the wetland. So at that point, I began to wonder, what did I do for the last 3 or 4 years at Penn? And was I wasting my time? So I took it on as a thesis. And the thesis was both landscape and architecture. And it basically said that you essentially, with a little bit of management, could manage this 18,000 acres to take on over 1 million people's waste and treat it into a life cycle sequence going into the sea. But in that process, I also happened to stumble upon, many times over, in fact, that wetlands were a humongous carbon sink, as we all know. So the wetlands were a better carbon sink than any of the forests or prairies or whatever. And so I started actually comparing the footprint of New York City to the wetlands, and how much, if we kept putting wastewater in, could that be a balanced system for the city? Now, of course, it wasn't, but it was surprising when I went through the numbers that I could get about 5% or 6% of the total balancing of the entire city of New York in 1970 with what was going on next door, called a huge managed wetland. Now that went on because McHarg's associates, not McHarg, but McHarg's associates were so happy that I discovered these kinds of things that they hired me in his office to do Newtown planning. So unfortunately, McHarg was being used as window dressing with EPA because he had the name to get New Orleans East trying to be built of 100,000 people in the Mississippi Delta. So the first thing I began to get into with his associate called Narendra, and I don't know anybody who knows who McHarg's associates were, but Narendra was really up on looking at new ways of thinking about, especially a city in a marsh that was being hammered by hurricanes. So I took this attitude of not destroying the marsh and building over it and on it. And when the hurricane came, sink the whole town and then pop it up when things were fine. But saving the marsh, I could save easily 6,000 acres. And that was the equivalent to what was needed to actually balance the 100,000 people living in that marsh by saving the bogs. Then I went to one next thing, and that was, how do you build the buildings? So I came up with this whole thing that I called the Mississippi was basically the asshole of the nation, because it took all the organic waste and plastic waste and everything and brought it right down past where this new town was being done. And I got interested in the process called pyrolysis, which some of you might know about. But pyrolysis is a technique of taking organics of various kinds and actually converting it into a series of plastic substances. Now, plastics are obviously not particularly good, but it is interesting that plastics are 80% carbon. So if you make plastics efficiently and you take the byproducts off the process of making them, you actually can come up with energy while you're doing it. And depending on the plastic and how you treat it out the other end, can be a carbon sink. Now, this is very complex, but that began to get us into lots of other things. So when I came to Texas, I became very, very conscious of waste issues. And the waste issues cropped up from very unlikely aspects. And that was that certain towns were getting shut off of their gas. And in South Texas, that meant either solar and or mesquite wood. And mesquite wood, as some of you might know, has a very high BTU per pound content. It's better than our coal, but it's renewable. So it began to turn over whole towns into getting mesquite wood stoves and so on going. And I don't have to tell this group what happened, lots of pollution. So then we went into solar hot water heaters. But an interesting thing that happened is that we had a lot of waste called sawdust. And so the Department of Energy said, Fisk, we like what you're doing down there. Put a grant in for a demonstration building that begins to pull some of these together. And so in a little town, Carrizo Springs, Texas, we began to do a series of things material-wise and performance-wise in the building that sort of captured a combination of these things. And the reason that I'm mentioning this capture is that this began to get us into thinking about how a string of processes could come together. And when we actually ended up doing the IOLCA GIS model of the country at the EPA, you obviously began to understand where things were happening. Where were the processes? What were you linking? By when you went and specified something, you're actually linking lots of processes and lots of industries. How far away were they? How did they link? Could you re-link them in other ways? So in South Texas, we began to link things. And so the mesquite sawdust wood became the first thing that we began to realize, wow, that actually could make insulation. With lime, which is very available in that part of the world, and caliche and all that stuff, we could actually stabilize it into an insulated block. Now the insulated block, and Bruce knows this because I keep pushing this at every other conference I'm actually asked to come to these days, which aren't many, is that you insulate the outside of your mass. So I insulated the outside of the mass caliche block in this demonstration building. And then I took my roof and I re-radiated it to the night sky and took the water off the roof from night and brought it into my slab. And thus the mass of the building, which was an earth material essentially, was actually the stabilizer, and it was stabilized by the fact that I used the wood waste as insulation to help make that process work. Now I'm going to skip. And the skipping began to happen related to not only this next town, beginning to make sense out of lots of little micro industries coming about, but then we were asked to do a number of other things. So somehow EPA and AIA and Bob Berkebile began to say, you know, Fisk, maybe we could do this at a more depth way at a national basis. Now, I was an overeducated refugee from the University of Pennsylvania, so I knew more craziness than I knew what to do with. And one of the many crazinesses was the fact that Walter Eisert presented this IO model of the US, which meant that he connected monetarily every single business to every other business. And if I actually had the silica sand go up in price, I could tell how much my glasses would go up in price, but I could also tell how much the glass in every building in the United States went up for high-rise buildings on through. So I said, wow, that's the most complicated damn thing I've ever seen in my life. I don't know what he's talking about, but that is an amazing situation. So when EPA and when the think tanks and so on said, well, Fisk, what would you do? And I said, I make an IO-LCA GIS model of the USA. And they said, what's that? And I said, I'm not quite sure. So then I began to gather people that actually knew what they were talking about. So some of these people, you know, Greg was a graduate from the industrial ecology end of MIT. And he had a good computer background.
Greg Norris?
So I said, you're hired, Greg Norris, right? So as we got this thing together, and EPA actually gave us a cooperative agreement, and I have to say, there are sort of a number of layers of things here that I think are really important. A cooperative agreement gives you a lot of freedom. And with a creative group like this, what we really need is money and time. And we could do extraordinary things. And EPA did not push the button every time, you know, we discovered something. They said, go and pursue it. Find out what you could do. So out of this, we had this model that ended up, you know, speccing the US Pentagon, speccing NIST buildings, speccing the Health Science Center in Houston, and so on. And it did exactly what Ed was saying. We could come up with a hierarchy of what is the low-hanging fruit, and what's the next, and what's the next. And one of the things that EPA was very conscious of, Fisk, you are not coming up with these things in your secret hilltop laboratory in Austin, Texas. You are doing these things, hopefully, with peer-reviewed people that actually have their shit together, and that we are going to a number of different agencies and saying, what are you doing that's connected to this? And how do those things actually help the peer review of this whole thing? Because EPA, and when you have a cooperative agreement, if you don't have what you're doing peer reviewed, it's not accepted in its final report. So we concentrated a lot on that, and we did a lot of work with CSI. And CSI at the time, and all their specification procedures, one began to realize very quickly that everything is decided. And Ed, I was so happy to hear that you were a spec guy, because it's the spec guy in the back room.
That's where it happens. Yeah.
It's the spec guy in the back room that actually is determining so much stuff that we're talking about. It's ridiculous. I mean, you can come up with a great design, and what the spec guy ends up doing with that design is either good or it's disaster. And so we kept running into this all the time. Now that began to get into other sorts of things. So we realized, you know, let's take single family homes. Wow, that's exactly what Ed was saying. Concrete, concrete, concrete. Where? Foundations, foundations, foundations. So all of a sudden you began to say, wow, you got to really take care of that, the single family home basis, before you go and do a lot of other things. And then it became an issue of, all right, what are the other things? And then we began to realize it's very difficult to go and carbon balance everything unless you have a balancing procedure within the building. Sometimes you can balance, sometimes you can't. But in this case, we came up with what we called CDIR, carbon dioxide intensity ratio. And carbon dioxide intensity ratio began to take all the life cycles of things in a building and then compare things. And it came out originally in the Journal of Industrial Ecology, where somebody out of Europe actually showed a neutral line, and all the thousands of materials above the line that were carbon problems, and all the materials below the line that were carbon solutions or carbon sinks. So it didn't take a PhD to look at this and say, wow, I can go and specify things in such a way that I can actually life cycle balance stuff. So we began to do that with a number of different buildings, with a number of different offices. Lake Flato's office in San Antonio. David Lake was an old student of mine, so he actually still believed what I said for some odd reason. And we went and actually did this within a building. And then we actually began to look at it related to office furniture. And lo and behold, some of the office furniture, the amount of materials that were actually a waste product that were actually compressed and had high carbon in them and had very short distance of travel because they were being done in industrial and urban areas, actually could balance the amount of metal in a lot of the office furniture as it existed. Not everything, and not totally balanced, but it was interesting going to some of these office furniture people and say, hey, you got carbon balanced furniture. And their answer, of course, and this wasn't too long ago, was so what? But then we began to look at a number of things to lower each end. So in other words, if you had Portland cement or a lot of steel, you need a lot of other things to balance that. And the aesthetics was very interesting, but the quantity of things became impossible. So the next question is, let's go and lower the amount of carbon in your cements. That's when we started doing a lot more, not only fly ash work, but more importantly, magnesium oxide work. And the magnesium oxide work began to say, hey, this is a byproduct of treating salt water. And not only is it produce the magnesium oxide, but it also produces fresh water. And if I switched my hat and I went to Howard Odom's stuff and Emergy and so on, water, fresh water, and its capability of dissolving and doing a whole lot of things that we assume is an energetic value that he called emergy. Now, when you begin to combine these things, you also begin to realize, oh my goodness, you're also getting hydrogen. So here you're coming out with a cement that, by the way, does not need fresh water to make the concrete. You can mix it with the salt water. So all of a sudden, these things began to compile on each other. And, you know, as Bob used to say, Fisk, you know, you're coming up with a plus ultra way of thinking about a materiality that actually has a lot to do with not just the life cycle and the way we've been thinking about life cycle, but think about life cycle as a series of industries and separate processes that in themselves produce very important things that we need. I'm going to come right up to present because this will be too long otherwise. So presently, somehow, you know, the community used to call us Max's Pot, standing for maximum potential. And I did put that bumper sticker on my truck once and got in big trouble. But maximum potential in this case is that here we're, could you guess it, in 2020, getting involved with the hemp industry to do what? A hemp house. So Max's Pot has come full circle. So the hemp house is kind of an interesting situation because it happens that magnesium oxide in its various forms does not deteriorate fiber, particularly natural fibers. So I can use natural fibers like hemp, which I don't have to tell this group is very strong stuff, and I can use it as reinforcement. And so I can use a magnesium oxide structurally or as a spray on surface for, because it sticks very well onto any number of different things, but that enables you to make surfboard type buildings, which means that you have very lightweight, extremely strong monocoque buildings coming out of the other end of this thing. Now, some of you might also know that the magnesium oxide is being used right now in many ways. Among others, it's fireproof. And so there are many things out there, including insulation that some of you have probably used called aircrete. It's almost 100% magnesium oxide, and it's one of the best insulations existing. So we're working with the hemp people and trying to come up with ways of, the chemistry term is plasticizing that foam to make it not quite so brittle, so that you can actually surface it with a combination of either the hemp bio plastics or the magnesium oxide or combinations thereof. But the extraordinary thing to sort of maybe end this is that, and this is a little bit, what would I say, impossible sounding, but true. So when you heat up many of these organic things into a carbonaceous base, that you actually come up with, in this case, nanofibers. And it happens to be that the waste fibers out of most all hemp processing, from CBDs on, has a fiber in it that when you carbonize it, makes a nano-based hemp battery that now Stanford University, Berkeley labs, and a number of other people are working on to make a battery that, from an environmental sense and embodied sense, by the way, carbon is a phenomenal carbon sink, as you might imagine. But now they have a battery coming out. So here this hemp house is becoming literally all hemp, all the way to the process, all the way to the point of the processing of the materials coming off the field, go into an industrial processing unit that separates this and separates that and so on. But the waste, part of the waste, not all the waste, so it's like an ecosystem. You're all not ever over optimizing any one part of the system. You save some of that waste for the material that goes into a gasifier. And so you all know that gasification is a way with low oxygen to come out with carbon. And the carbon that everyone's really excited about is biochar. So biochar is a phenomenally important way of building soils.
I want to time out here, Plenty, because I think
And two more words. So biochar going back into the hemp crops actually enables a circular economy going on. And that is the direction of eco-industrial ways of thinking that I think we should be more conscious of. Thank you very much. Was that too long, as usual?
The
I just
part
wanted to give
that-
Kate and Ed a chance to say goodbye because they have to leave.
Yeah, I'm
Okay.
just
Okay.
sad I'm not getting to keep going here because this is great.
Yeah, it's
So-
very fascinating.
So Bruce, I just want to say that I think I can't wait to hear what Anne has to say. So I hope
Yeah.
you'll share the recording so I can hear it.
Yeah.
And I think this is really intriguing. I mean, it makes me think of oral history documentation.
Yeah.
So yes, I do want to encourage you to continue to follow up with Ray Cole and who else are we?
Craig Jones.
Wayne Trusty.
Trusty,
Trusty.
Jones. You might even talk to Bruce Lipke, who did a lot of the work around wood LCAs. So I don't know, maybe you and I can follow through. I know you have a book that you're trying to get going, but I do think that it's worth kind of making sure we don't forget the arc of where we've been and where we're going.
Yeah.
So this is great. Sorry,
Hey,
to
guys. Kate, take care.
bye.
Great to see you
Hi,
both.
Kate.
Yeah, and Bruce, you call me anytime you need any more information, whatever. And I'll see your recording.
Okay. Nice to see you both.
Yeah, it's great to see you all. Plenty good to see you.
Right.
Yeah, and great
Good
to
to
hear
see-
this. Great to hear that whole story. It's
Yeah.
I'm going to look up magnesium oxide now.
Yeah, Plenty, will you, do you have anything you can send us? Because last I heard about magnesium oxide is it was too much energy to extract it from ocean water. It's in very dilute form. So this notion of it being a byproduct of the desal, like they're doing big time in the Middle East right now,
Yeah.
that's intriguing. So if you have anything you could send, I'd appreciate it.
Yeah, and
Too
anything
much.
anything
Yeah.
on concrete. I've got to address the Global Concrete Association or conference in about 2 weeks. So I'm starting my research.
Oh,
on
I'm
that.
going to be talking at that too, Ed.
Are you? Yeah,
Here's a fun one for all of you, because we're writing this book, and 10 billion tons a year of concrete. That's what the world makes, 10 billion tons. And you think, wow, that's a lot of concrete. You know, we all hear big numbers all the time. So I did a little math. 1 ton of concrete makes a cube almost exactly desk height, 29 inches high. 10 billion tons of concrete every year makes a cube a mile high. It's 6 times the height of the Eiffel Tower every year. So this whole thing that you keep, you know, Architecture 2030 gave us this thing, another New York City every month, all in the
There we
middle,
go.
and not here in North America. We're not doing anything in North America. It's all China and India and Africa. And it's mostly concrete. So this book, I'm supposed to write the chapter on mineral architecture with metals and plastics and concrete. And concrete is already like a book in itself. It's going to be,
It's huge.
that's
Yeah.
unbelievable how many people are doing so much stuff around concrete and cement and everything. It's exciting. It's really cool.
Yep.
But
I can send you lots of stuff.
please do.
Yeah, copy me on it.
Okay.
All right, guys. Bruce, thanks for
Okay.
pulling this together.
Thanks, Ed. Thanks
Yeah,
everybody
you-
for coming.
If you need anything, let me know.
All right.
Great seeing you, Ed. Fantastic.
Good seeing you all.
Yeah.
Kate, everybody.
Yep, bye-bye.
Well, Ann,
Oh, my goodness.
you'll have a full audience because I don't know how many millions of people will want to watch this recording.
Right. Well, plenty. I have to break it to you, though. You're not the oldest. Ed is.
Oh, he is?
He's got 4 years on you.
Really?
Yep,
So he's 80 years old.
that is correct.
Wow. Well, that's encouraging. Not to be the oldest.
Yeah, it's pretty fun listening to all of this, though, because it sort of reminds me of, where I've been, where I came from, and, those of you who have been important influences for me. But it's also a reminder that I'm such a pragmatist. It's like, you're a scientist, Ed's, I would call him a synthesist. It's like Kate's a mobilizer, and I feel like I'm the pragmatist. And so I'm always looking for, okay, what needs to be done next? Like, all right, what do we do here? So let's see,
Great combination, by the way.
that's
I like
true, right? Yeah. It's like
Not a bad team.
one of my favorite analogies to use when people sort of say, well, what should I be doing? We're like, oh, isn't it better to do X than Y? And say, look, in a revolution, you need everybody. You need the people with the battering ram at the gates. You need the people on the inside, tunneling, infiltrating and whispering, and everybody's got a role. So it's just all about what is your role. So for me, where does this come from for me? Bruce, you asked, like, what was the inspiration? Honestly, I think a lot of it was innate. I feel like I was born with this just innate abhorrence for waste. And so that's really driven so much about my career trajectory.
Me too.
It's like, I just can't stand it, and you can't work in this industry for very long without being just, have your hair on fire because of the waste, in so many dimensions. So, yeah, I have to fast forward through a lot of my early career. I guess that the easiest thing to say is that, let's say for the first, 15-ish years out of my bachelor's program, I did a lot of residential remodeling, and I learned a lot about houses. So that was sort of set the ground for a lot of my later work. But I didn't really know what I wanted to do with myself. And finally, this green building thing came along that wasn't really even called green building. I have no idea what anybody called it back then because my memory no longer serves. But so in the late 80s, it was sort of like, okay, this is good. This fits with my environmental ethos, that's where I'm headed. So I went back to school at UC Berkeley, 1993 to 95, exclusively to focus on this thing that wasn't yet called green building. And I kind of came in already having resolved to myself that we needed to be building with nature. And so I got involved in the natural building thing. And that's how I met both of you, is through the straw bale world. But one of the things that happened within the first year really was I realized there were a lot of people in the straw bale movement who unquestioningly held this belief that straw bale's better because it's a natural material and you can grow it. And I'm also something of a skeptic by nature. And it's like, okay, yeah, maybe. But there's this whole thing about when you build with straw bale walls, the walls are this wide, not this wide, and the roof has to be that much bigger. And so I started to say, well, yeah, let's question that premise. So that ended up being the core of my research in 94, 95, and during which I essentially developed a possibly the first whole building LCA tool. In Excel, before you could even copy and paste Excel into a Word document. So my thesis is still a patchwork of different programs. But what I did was look at embodied energy as a proxy for carbon, because it was emissions I was interested in at that time, and also waste and water. And so I looked at the impact of choice of assembly on the whole building for those three parameters. And the conclusion I arrived at was, drum roll please, no, you guessed it, it depends.
Yeah.
Right? Like that's right. Like it's kind of the mantra we have all adopted over the years. So that was kind of where I started with this. And then I continued to focus on materials. And I think materials is sort of for a long time, really, honestly, until the last few years, has been sort of the forgotten stepchild in the green building world. Not because it's really forgotten, but because it is so damn complicated. There are no easy measures for it.
Yeah.
And, one of the things I arrived at one of those earliest natural building colloquia, I became very enamored of the Gaia Norway group's sort of 4 basic principles. At the moment, of course, I can only remember 2 of those, but they were essentially make your materials as local as possible and as least processed as possible. I was like, you know what, that's pretty damn good. And I think it's still pretty damn good because it really gets to a lot of, the problems we have with materials. We move them around too much and we process them too much. And that's where most of the energy goes in, right? And therefore the emissions. So I really kind of operated on that premise for a long time. And coming out of my graduate program in 95, I initially worked with the Wood Reduction Clearinghouse for a couple of years, and then NRDC. And during the NRDC years, was tapped to head the Lead for Homes Committee for USGBC, as well as to co-chair the Materials and Resources Technical Advisory Group for the family of LEED programs. And so in those roles, I continued to sort of champion these sort of key attributes of materials. Again, let's keep them with as little processing as possible and as local as possible. So we managed to sort of bake all those attributes and others, durability and so forth, into the LEED materials credits. And, they're still there, and they're, I think, the foundation of where LEED has evolved to and where a lot of the industry has evolved to with a lot of outside influences. Believe me, I do not credit USGBC with so much of this, it's been, I think, a powerful convening force. But what it convened was a lot of creative and smart and collaborative people from all over to provide a platform for the conversations that needed to happen to bring all of this knowledge and intelligence together. So during that time, I also co-chaired what was known as the Wood Sub-Technical Advisory Group, which was the platform for the Wood Wars, which really had a lot to do with not only making sure that we were making appropriate use of wood, but that it was the good wood, sort of looking at wood more holistically. Boy, was that exhausting. That went on for a long time. Anytime you're up against an industry lobby, it's like beating your head against the proverbial concrete wall.
I think we've all been there on this call.
Yeah.
We got the scars to show for it.
Oh my goodness, yeah.
You ought to try the concrete mafia, by the way, sometime. They're worse.
Yeah, I believe it. I mean, well, the reality is that all the lobbies are relentless. It's like they have essentially infinite resources to pit 24/7, and they will never be satisfied. That's their nature. It's like they don't have an end game. It's just always the more. So anyway, that's a whole other story. So,
but an interesting model, and for us all, is the hemp industry has figured out a lot. I don't know how they've done it, but these guys have their fingers in every state, government, national, wherever you are, they're folks present.
it's probably because the mainstream industry views them as a laughing stock and they have no idea.
Yeah,
right? It's like, oh, those hemp guys, aren't they funny?
Exactly.
Those damn hippies.
Exactly.
On
I'm
that subject,
constantly astounded.
I have to add something that I was invited by a guy named Henry Bowles in Austin. Plenty, maybe you know him. He's a realtor, but he's really into hemp building.
Yeah.
And he called me, said we're forming a U.S. or a North American Hemp Building Association. You might want to join in. It was a Zoom call. It was last spring, I think. I said, yeah. That'd be interesting. And what was especially interesting to me was that there were like 300 people.
Oh yeah, exactly. There are lots. They're everywhere.
People are into hemp. People are really into. I mean, yes, it's a cool plant. There's a lot to it, but it just struck me like, who are you people? And most were not engineers or architects or scientists. They were just people.
Yeah.
Damn
hippies. I was given
hippies.
the list nationally of how many organizations there are like that. It's wild. It's nuts. But a lot of these guys from the building standpoint, they think one thing, hempcrete. And that's it.
Yeah, right. A little bit stuck on that.
A little bit stuck, man.
But let's let Ann finish because you didn't.
No, I didn't. So yeah, let's see, that materials focus really kind of took me up through about 2008, with a lot of time dedicated to, again, my various, numerous hats in the LEED empire. And once we kind of kicked Lead for Homes out the door, again, my question to myself was, okay, what's next? What's the next big lever? And the answer was net zero energy, because to me, it was all about climate at that point. And it was very clear to me that USGBC was not moving nearly fast enough on climate issues. So I pretty much jumped that ship and put my shoulder to the wheel and wrote, as you know, Energy Free Homes for a Small Planet, which Green Building Press published. And that has been really a very, I'm not going to say exclusive focus, but a real central focus for my work, honestly, for the decade, let's say from 2009 to 2019 or 2018. However, for me, the whole embodied carbon thing has always been in the background. You know, it's like I've always been concerned with materials. And somewhere around, I'd say 2013, 2014, when the country and the Bay Area in particular was coming out of the slump after 2008, construction in San Francisco was going absolutely apeshit. And I was attending a lot of meetings in downtown, and I was very troubled by this. It got me just viscerally concerned about the embodied carbon in these enormous high rises. And I started to think about this and go, this is sort of, again, my question in grad school. It's like, you know, the orthodoxy around high rises is, well, you know, density is good because it provides, you know, the basis for transportation, and we need to reduce VMT. And we also need housing. And so density is good. And once again, I was like, yeah, maybe, but not so much. And is anybody looking at limits? Going back to Danella Meadows, limits to growth? You know, is there an upper end to appropriate and healthy, climate healthy density? And I started talking to some colleagues about this, colleagues in the green building industry, people who were, you know, really forward thinkers. And I got blank stares. And I thought, wow, is it just me? And there were a few people who were like, yeah, I know what you mean. It's really bothersome. But nobody had really done anything on this. Not too much. So I started poking around, and then Bruce approached me about this other book, New Carbon Architecture, and said, do you want to write something? I was like, yeah, I do. I've got this subject that's really been bothering me, and that'll give me a great excuse to pull together the research on it, which I did. And so, Bruce, when did that come out? 2016?
4 years ago. I wrote it during the election of Donald Trump, and now I'm writing its successor during the election of Joe Biden.
There you go. Good. Yeah. So 2016.
This is good.
Yeah. So 2016, that book came out and the chapter, and I have to say I haven't done a ton of research since, but I have kept squirreling away more articles that come along that honestly continue to bolster my concern about this. And it's not necessarily a, you know, global universal concern about high rises. It is more specifically concern about high-rise construction in developed contexts where there is already pretty high level of good transit infrastructure, and where the introduction of more people and more development both causes huge disruption in terms of what it takes to provide the necessary accompanying infrastructure that isn't already there, because it isn't. It's never enough. We'll never catch up. And the traffic impacts that go with it, including their emissions. So it's kind of this bad feedback loop. And where I arrived at the conclusion of that project was there's probably a sweet spot for buildings somewhere between, say, 6 and 12 stories. And as you know, Bruce, and plenty of you, if you read the book and the chapter, where I end is not so much with conclusions as with a list of questions. Pretty long list, as I recall, maybe 20 or 25 questions that need to be answered in order for us to really understand this. And a lot of those questions revolve around the types of things that you all and Ed have been talking about sort of setting targets and benchmarks, but also around policy. Where this has really led me to is, I believe, and this speaks to your question about leverage, Bruce, I believe that we have, understandably, those of us who are in the business of creating or shaping the way buildings are created, perhaps neglected the crucial importance of policy, particularly types of policy that affect land use and urban form. And I've become really acutely aware of how planning policy dictates form and how form dictates the way we use materials. And so my thinking at this moment in time is, okay, now we need to use what we know about embodied carbon and its role in buildings based on typology to craft policy tools that can be utilized at a municipal or even state level to say, let's assign our very, very limited embodied carbon budget. You know, we know we have to husband this incredibly precious and dangerous resource of embodied carbon. We know we need to husband this carefully. So we should be allocating it to our highest and most important uses. And as far as I'm concerned right now, those are around housing the unhoused in appropriate ways and bugger all the rest of it, you know, quite frankly. You know, it's like, I think given where we are right now with the pandemic, with economic and social injustices, I think that we should be exclusively focused on remedying those conditions. We should have an absolute moratorium on building anything that resembles an office or any sort of place of congregating, because we don't know realistically what our future looks like in terms of our ability to congregate. This is not the first pandemic. It's not going to be the last. And the next one is going to come a lot sooner than a century from now. So I think we should be saying, look, let's get the people that we have absolutely treated as waste in our society. Let's turn those into healthy, whole people who are sheltered again, and not waste our embodied carbon on anything else. So that's where I am with
Wow,
this.
cool.
Well, yeah, except that, like, I'll just wave my magic wand and make
Yeah,
that
right.
happen,
Yeah,
right?
Well,
But you know, go
as
ahead.
I'm writing, I gotta take that. I'm writing the chapter on policy and governance right now, which just like concrete, it's enormously complex, of course, and there's a lot happening. I've been part of it. We wrote a concrete code here in Marin County, low carbon concrete code, and now it's spreading. It's going around and replicating in various ways, and that's all very interesting. But I don't think it's a really very good lever. It's the lowest on the list of Dana Meadows' list of levers, which can sometimes turn out to be a powerful lever. We'll see. But I'm going to interject for the sake of the recording. My own quick bio is I'm a structural engineer who was asked to work on a straw bale building 30 years ago, the Real Good Center in Hopland, California, which was timely for me because I was already only 5 years into my career as a consultant, just dead ass bored with being a structural engineer. It wasn't interesting to me. And so now there's this nascent world of green building and people doing alternative stuff and what we now have come to call the natural building movement. And I got all involved with that, and I ended up writing some books and getting grants and doing research, and having a good time, meeting a lot of good people. But at the same time, and this is a very parallel story to yours, Anne, both literally because you and I were working together on all sorts of things through this, but in my own evolution, I was working with all these natural building people and going to these fun gatherings where there are lots of guitar playing and beer drinking and fun people. But I'm thinking, you know, this is not the future. These people think they're going to save the world because everybody's going to go move into the woods and have a cob house and a straw bale house. It clearly wasn't the case. They just hadn't traveled very far beyond their own borders, beyond their own imagination. I'd seen China. I'd seen Africa. I'd seen a lot of places where that just wasn't relevant. But I thought there must be some principles here. And I'd forgotten that the guy in Sweden, who was it who did the natural step, the 4-step program, 2 of which were keep it local and don't process it too much. Who was that guy? Hans Erik something?
Damn, you're taxing memory, man.
We haven't heard from him for a while, right?
Carl something Heinrich.
That's right.
Yeah.
But I arrived at those 2 principles myself. I said something about natural building. There are underlying principles that are relevant to a world that now has, I just checked, 3 times as many people as when I was born.
Karl Heinrich Robert.
Yep.
Yep.
And that what makes natural building is you're using what's local and you're not processing it very much. Simple, short supply chain.
Yeah.
And that's it. So that's what I go around talking now. And I arrived at the thing separately from Carl with all hats off. And I'm sure I'd read that stuff. And so maybe it was lodged in my mind, but I sort of had to grind through it on my own, hanging out with straw bale and cob people and people who thought bamboo was the answer to everything and so on. All of whom were partially right, but also partially wrong. You got to start thinking systems. Do you ever try studying systems theory, Pliny? It's very interesting stuff, and I think you should check it out. It'd be very relevant to what you do.
You know, to be very honest with you, it so totally destroyed my mind as I got out of graduate school, getting exposed to Russell Ackoff and general systems theory, that then I measured everything by that. And the only reason that I did this craziness with EPA is that for some reason I thought I had the background to at least enter into that arena.
Yeah.
A la input output. Yeah. But that is crucial. I mean, the Austin Green Building Program came out of Ashby's Design for a Brain, but I never told anybody. Ashby was a very well-known cybernetician. But you know, there is a very interesting book coming out that connects to both of what you're saying. So there's a group called Rutledge that you both know, which is out of London. And they have financed a book called Bioregional Planning and Design. And they asked me to do the chapter on bioregional design. And one of the fantastic things I was able to do is to go back and really map how we did what we did, both from a people standpoint and from a natural resource standpoint and the network standpoint. Me. The Center for Maximum Potential.
Yeah, okay.
Yeah. And so that is coming out in a few months. But what was really important about it is to put down the process that enables one to understand place. And so you begin to really connect people, their skills, businesses, the next generation of how materials need to be used and how this next step evolution of retraining, of repositioning, of redoing this needs to happen is a very huge task, but possible as you begin to really dive down and look. The other thing, by the way, is Ralph Knowles, we all know, and I was hoping that you would suggest in your rethinking of our new Congress for New Urbanism that we ought to rename called the New Congress for Building the Future or something, how important his work was related to sun, because what's going on is we're blocking the sun.
Oh yeah, absolutely. Yeah, well, blocking the sun and creating wind tunnels.
Exactly.
You know, it's like that. It's just, yeah, that's definitely in the chapter I wrote as among the sort of qualitative impacts. And of course, the sun piece, I mean, you can quantify these, but nobody's really doing that very effectively.
Well, Ralph did a very good job on a lot of that stuff.
Yeah.
In his form code stuff.
I'll have to reckon back to that.
Anyway.
So yeah, there's some really interesting stuff in the form-based codes. In fact, I've been looking at some of that recently. Bruce, you might be interested. There's a set of form-based so-called objective design and development standards that's being proposed for Marin County. And they use a lot of stuff from form-based codes, but it's done in a really kind of clueless way where they're basically just saying, oh, well, here's, if we look at Marin the way it is now, here's a form-based code to replicate that. And the person who brought this to my attention was just like, and you know, and showed it to me. And likewise, it's like, oh Jesus, you're like, no, it's like, okay, sure, you can start to document what is, but then you have to overlay what needs to be.
Yeah.
And they haven't done that at all. So be aware that this is going on, and it's pretty
Yeah.
alarming.
I hadn't heard of it. And I don't know what a form-based code is. What do you mean?
Yeah,
Well,
it's, go
usually
ahead, Plenty.
setbacks from the street is basically what it is. How much area do you leave for pedestrians, cars, bicycles, and how do you set back enough from the street that sun actually comes into the street? That's as far as they get to related to the sun. But then there's a whole bunch of other stuff that Anne's probably studied much more than I have.
Well, I don't know about that, but it's basically just saying, how do we describe an urban context in a way that sort of we're physically describing it by, like how big are the volumes? You know, do we have overhangs? Do we not have overhangs? Are they, you know, do we have gables or flat roofs? Or, you know, it's basically saying, if we were going to create a Lego set or a Thomas the Tank Engine train set, and we wanted to make all the pieces look like they go together, how would we describe it?
Yeah, in their language, not our language. It would be very interesting if we put our language on this.
Yeah.
Well, yeah, and this is the problem. It's like, okay, there are some attributes of these existing forms that are appealing and charming and have served us well, and there are others that have not served us well, and that certainly won't serve us well into the future.
By the way, do you know a office called Generate?
No.
Because they've done some studies on high-rise buildings and embodied energy, as well as operational energy.
Huh.
And they go through the gamut, and they have beautiful graphics that sort of summarize each building type in a high-rise sense. But I will also forward that to you guys.
Oh, good. Please do.
Yeah, because Anne's going to be rewriting this chapter she just described.
Yeah, we'll see about that.
Can we have it in can you do that in the next 3 weeks, Anne?
Yeah, right.
So the book is being reissued, huh?
Well, it's a different book. I'm doing it with Chris Magwood, who did the seminal paper, his master's thesis in Trent University on carbon storing buildings, carbon positive buildings. And a wonderful peer-reviewed work. He said, look, you can go and build the typical residential 6-unit, I think his model was a 6-unit apartment building in the Toronto area, off-the-shelf stuff at Home Depot, and you can do a carbon storing building rather than an emitting building.
So are you getting into anything that might be called an eco-industrial support system that actually does circular economies, and we're triggering a circular economy by how we're speccing and what we're doing?
We're going to only touch on that. We're going to be so focused on buildings and their constituent products and materials, but it's more than we can handle to look larger than that. That said, if you would like to contribute something, I'll write to you and say, this is what the book is. But there's all sorts of things that we're going to have, contributing essays and so on, that give context. Like there's this Black architecture professor up in Seattle who's doing this wonderful work in the neighborhood where they're going to turn church property into housing for the poor and make it low carbon, both embodied and operational. They're aware. Very cool story. I asked him, would you just provide a short piece about that we could publish as part of the book? And then about what's happening in China, what's happening in India, all sorts of contextual things, but we can't do a proper job of studying anything. It'd be great if you wanted to, a couple pages worth, 1,000, 2,000 words would be great.
Well, what I might do, if you absolutely promise not to pass it on, is send you the chapter that I just did for Rutledge. To give you an idea.
I won't pass it on, and maybe you could rework it a bit because it might be just the thing, but we wouldn't want to republish it exactly.
Now that didn't well, yeah, okay, could be, but yeah.
Certainly, yeah, I'll keep it to me. That'd be great, Plenty, because I know there's all sorts of larger scale things that we do think about, but we just don't have the bandwidth to handle for this book.
Yeah. Well, it's just that's what the whole IOLCA effort with EPA was pointing towards. And I keep hoping and praying that somebody will go to that next step and say, it's got to get beyond the boundary of the building, beyond the boundary of the city. It's got to really look at all those Trumpian rural areas that go and think they know what they're doing. And we could actually help redirect things in such a way where regenerative agriculture and regenerative materials and regenerative all kinds of things could make a huge difference from the economy standpoint, but also in a carbon standpoint.
Yeah.
But just, somehow cross that boundary.
Not to mention a social standpoint. Wouldn't it be lovely?
Exactly.
Wouldn't it be lovely if this horrible violent schism in our country
Oh man,
could somehow go away?
it's unbelievable.
If we could somehow bridge it.
Oh
That's
yeah.
a bridge I would build with anything, with any material that would work. I would build that bridge if I could.
Man, I kept that New York Times map of the United States, by the way, and where the blue and where the red and orange are in dots related to every town and every city across the entire
Just a
country.
big purple mass.
Yeah, man.
Yeah, that was some fabulous mapping,
That was unbelievable.
right? I was riveted to that website for
Yeah.
the better 5 days
Yeah.
because it was just so illuminating. I mean, I've never ever followed an election like that, and it was, of course, I was very concerned about the outcomes, but also it was just so well presented, and it gave you so much information to chew on.
And it basically also says what problem we have.
Yeah,
Huge
absolutely.
problem.
Yeah. Oh yeah, definitely. Yeah, I was talking to my sister yesterday, and she was sort of, lamenting the same thing. It's like, I said, well, this is overly simplistic, of course, but I come to two conclusions. One, our media is hugely compromised. It's like we do not actually inform people. And secondly, economic insecurity breeds bad behavior.
Exactly. Exactly.
And of course, I mean, the irony here is because of the misinformation, those most affected by economic insecurity somehow believe that Trump is on their side when exactly the opposite is the case.
Yeah, and it's a little bit due to us as well. I mean, we don't quite know how to bridge properly into the vocational programs,
Right.
the, community
yeah.
colleges, into all these things where those are the people that go out with the skills and knowledge to go and create the small businesses of the future in actuality. And that was where all those people go, is to the rural areas or around the cities.
Yeah. Yeah.
I'm always toying with the idea, you two can appreciate this, of writing an alternate history of the straw bale revival. That instead of Plenty Fisk and Bill Steen and Dave Bainbridge, who else was there? Up in the mountains there near Oracle.
Oh yeah, there are a lot of people. Ken
You
Haggard.
could go back further to John and Davis, but just a few seminal moments became the straw bale revival.
Yeah.
And what if you had all been, Trump people, basically, preppers, survivalists, live off the land, but completely different politics. It might have still just gone just as far and just as fast.
Yeah.
And it would be a politically red thing.
Yep.
I don't know. I don't think so. I think there's something too visceral about building with straw and the way it builds community. I just don't think that could have happened. Anyway, guys, I got to run.
Yeah, I do too.
It's been lovely. Yeah.
Bruce, thank you so much for getting this together.
You're welcome. We might even do it again. I might try to do it again and get the rest of the gang in here.
Yeah, that'd be
fun. I'll put it in a place where it can be seen. So I have to figure out how to post it online, but I will do so. Plenty, send us all those papers.
Okay. And it would be great. I mean, Wayne Trusty and all these, Ray Cole and
Lawrence Doxey.
Lawrence Doxey, all critical people.
Yeah.
Lawrence is in a little bit of trouble because his wife Carla is in trouble. So
Who's that?
here, Lawrence Doxey's wife has been in a
Oh,
lot of trouble.
oh no.
So there's a lot of, there's not been a lot of connection.
Oh, sorry to hear that.
Yeah,
Shoot. And Greg Norris, another one.
Greg Norris, exactly.
Greg, yeah.
Yeah. And there's
Yeah,
who's the person who was behind bees? Nobody mentioned bees, but that's
Oh,
another
yeah.
part of this history.
And there's Andrew Alcorn in New Zealand who published all sorts of great stuff over
Yeah.
the decades.
Yeah.
Well, Bruce, as usual, you're a catalyst for getting people together. So we're counting on you. And
That's right.
if you want us, by the way, to push Ray or Wayne or whatever,
I may do
I'd
that.
be willing- yeah,
I may try to get the band back together again, like in December sometime, and get
Cool.
everybody on board.
Yep.
Wonderful to see you guys.
Likewise.
Be well.
Appreciate it so much.
Bye-bye.
Bye-bye.